Nomenclature 3 did not get created yet. It will be about drawing cyclic structures, both cyclic alkanes and bicyclic alkanes. We did it during lecture, so it will be a video for a future semester. Right now, we're going to deal with what's called stereocenters. Stereocenters are an atom that has 4 different groups. We're going to label them with an asterisk. This is a stereocenter. It has 4 different groups. It has an ethyl group to the right. It has a hydrogen down here, a fluorine here, and a butyl group to the left. 4 different words, 4 different groups. To establish whether it's an R or a stereocenter, R or an S stereocenter, we must follow the following steps. You're going to prioritize groups as 1, 2, 3, 4 using this criteria. Heaviest atom on the stereocenter is fluorine with a mass of 19. It gets a priority 1. Lightest atom gets a priority 4. It is hydrogen. We have what's called a tie for a carbon and a carbon. We must learn how to break ties. They are very commonly encountered. To do it, I'm going to copy the part where we don't have numbers yet, break them down a little more fully. They are both CH2s. How do we break a tie? Keep moving away from the stereocenter. Ask yourself, what is the heaviest atom attached to the stereocenter? If it's a heavier atom than the heaviest atom attached to a different group that is the same distance away, then you have a winner and a loser. Repeat until all ties are broken. All right, so the question is, what is the heaviest thing attached to this atom moving away from the stereocenter? Answer is a carbon. What is the heaviest thing attached to this tied atom moving away from the stereocenter? Answer is a carbon. We still have a tie, but it's a different distance away, so I will change the color of those to reflect they're not being compared with the purple atoms. Okay, back to your tied atom. What is the next heaviest thing attached to the tied atom? A hydrogen. It ties this hydrogen. Next thing on this one, a hydrogen ties this hydrogen. We have compared all things attached to both the original tied atoms, and we still have a tie. We must break this tie. My apologies. This tie. Keep asking the question. What is the heaviest thing attached to this moving away from the stereocenter? It is an H. Heaviest thing attached to this one moving away from the stereocenter? It is a C. Compare the C to the H. We have a winner. A winner and a loser. Which means we go back to our original stereocenter and we give a higher priority to this carbon to the left than this carbon to the right. Winner on the left, loser to the right. We have decided our 2 and our 3. So you've finished with part 2. Even the tiebreaker part. On this page, part 3 is done for every molecule. In part 3, you're supposed to reorient the molecule so that the number 4 group is on a dashed bond. I've made sure that it's number 4 group on the dashed bond for every stereocenter on this page. In Nomenclature4 video, you'll learn how to do the reorientation using what's called a double switch. We are finally ready for part 4. We're going to connect group 1 to 2 to 3 with an arrow and then look at it from there. I have some curved arrows here. 1 to 2 to 3, a little too curvy. There. 1 to 2 to 3. In our final part, ask yourself the question, is that arrow clockwise or counterclockwise? The answer is clockwise. Equals R. Name of the molecule. I'm going to go a little fast on this part. Following the rules we learned from last time, we start the chain from the right side, putting the fluorine on carbon 3. Name starts with the stereocenter's name. R, 3, fluoro. 4, 5, 6, 7, heptane. If you are to be really picky, the R should be italicized. Congratulations, you've done your first stereocenter. Moving on to our next stereocenter. This is a stereocenter. This carbon is not. Even if I had it drawn with a wedge and a dash, it is not a stereocenter. Why? Because a methyl is the same group as a methyl. Let me describe the 4 different groups on this stereocenter, which is what makes it a stereocenter. Methyl, hydrogen, CH2 attached to a branched C, CH2 attached to a C that is not branched. That C is clearly different. Whoops. That C is definitely different than this C down here. So we have one stereocenter in this molecule. Priority 4 is a fairly simple decision. It's an H. Some of you might be thinking the 4 is always an H. Later on you will clearly have to modify your thinking. The 3 is a methyl. Why is the 3 the methyl? What is the heaviest thing attached to this C? The tide C. The heaviest thing attached to that C is an H. Moving our ties over again. Heaviest thing is an H. Which is a loser to this C and this C. Notice all the red things are the same distance from the stereocenter. So we've established our 3, the loser, the red loser. What is this? Breaking the tie here involves us going a little further on. I hope you see they're both CH2s, so there's no need to compare the H's. And I hope you see there's a tie up to the red C's here. And I hope you see that this red C has at least one C, which would be a further tie. With this C here, same distance from the stereocenter. Go back to the red C. These are H's. We only need one of them to prove that we have a loser. What is that H attached to? From a blue labeled tied carbon. We have not compared this carbon yet. That is a winner. baby blue winner, baby blue C. Comparing this C to this H, the same distance away from the stereo center, we have a winner and a loser. Allowing us to finish off the stereo center. The 1 is the thing close, is the original tie closest to this winner. The 4 is the hydrogen. We can copy that over here as well. And the 2 is the carbon that was the blue loser, light blue loser tie. Right there. Notice we always put the numbers on the direct bond away from the stereo center. We break the tie further on. Alright, we are allowed to connect 1 to 2 to 3. It looks like we're on a bit of an R fest here because the direction of this curve, once again, R. So naming this molecule, the name of this molecule is R113 trimethyl cyclohexane. While you weren't watching, I put these numbers on to indicate the lowest possible locations for the groups. 2 groups on 1 and then the 3rd group on 3 is the best numbering system based on last week's nomenclature. The molecule underneath has 2 separate stereo centers. Let's make sure we distinguish them. This stereo center has an ethyl, an isopropyl, a normal propyl, and clearly a group that is not an ethyl, a propyl, or an isopropyl. This stereo center has a methyl, a bromomethyl, an ethyl, and clearly a group that is not a bromomethyl, methyl, or ethyl. We're going to have to learn how to do multiple stereo centers in the same molecule. Each stereo center is its own separate problem. So doing the first stereo center, I hope eventually you get a little better at this and realize that the 3-way tie with the CH2s is going to lose to a C that has only one H and a second C. Both of these CH2s go to a C that's a CH2 that goes to another C. The same cannot be said about this CH2. It goes to a C that has 2 H's and yet another H. The H is a loser. Eventually, you'll get to a point where you will quickly see the CH2 on the right is going to beat the CH2 on the left because it remains tied up until this C, the 3rd C away, ties the 3rd C away. That C has nothing but C's. This C has nothing but H's. We have our 2 and we have our 3. That stereo center finally goes in the counterclockwise direction, connecting 1 to 2 to 3. That is a counterclockwise orientation. So that is what kind of stereo center? That is an S stereo center. Not R, but S. The stereo center on the right. After you've practiced this many times, you're going to realize that CH3 is a C with nothing but H's. That's going to lose to all the other C's that are attached. The winner is the C that has a Br attached. Which of these 2 CH2s is going to win? Well, a CH2 on the right that goes to a CH3 is going to lose to a CH2 to the left that goes to a CH2 that has a C. The C beats the third H, or one of the H's off of here. That gives us a 2 and a 3 here. Make that a 3. Change the colors of these numbers so you know you're talking about a different stereo center. We have a second S stereo center in the same molecule, connecting 1 to 2 to 3. Clearly a counterclockwise venture. So that is also an S stereo center. Nomenclature rules say that carbon 1 should be here because we'd get a group on 3, which is better than starting from the other end of the longest chain, getting a group on 4. We have a group on 3, 4, 5, 6, a group on 6, on a chain that goes to 9. Let's just copy this name here and edit it as need be. How do you indicate that the multiple stereo centers are on different carbons? Put everything in parentheses. Tell me that the stereo center on 3 is S. Tell me that the stereo center on 6 is also S. This name is all wrong. We have bromomethyl listed first on carbon 3. We have ethyl listed next on 6. We have isopropyl listed next on 6. We have methyl listed last on 3. Groups going alphabetically. 9 carbon chain, non-A. This video is getting quite long. I believe we're going to pause here and do the other 2 molecules in the next video.